Tangential speed. Tangential speed is the speed of an object in rotational motion when it's let go. When an object is let go, it will go off tangent to the circle when it's released. So we need to know what the word tangent means. Tangent is a line that touches a circle at only one point. The units for tangential speed are meters per second. And to calculate tangential speed, we would use this equation here, where v sub t stands for the tangential velocity, or the tangential speed. That w stands for the angular velocity, and r stands for the radius. So to calculate the tangential velocity of an object when it's in rotational motion and it's let go, we would take the angular velocity and multiply it by its radius. Now remember that angular velocity is the change in the angle per unit time, and it's in terms of radians per second. So we would have to calculate the angular velocity first, and then multiply that value by the radius, and that would give us the tangential speed of an object in rotational motion when it's let go and it flies off tangent to the circle. So let's look at a practice problem. Suppose a ball is tied to a 0.20 meter string and swung in a circle. If it takes 5.0 seconds to complete 20 revolutions, the first thing we want to do is calculate the diameter of the circle. So think about the ball on a string, and we swing it around in a circle. That 0.20 meters is considered to be the radius of the circle. So if we want to calculate the diameter, we know that diameter equals 2 times the radius. So we would take 2 times 0.20 meters, and that would tell us that the diameter is 0.40 meters. We can calculate the circumference of the circle, or the distance to go around the circle, by using our equation circumference equals pi times the diameter. So we would take 3.14 times 0.40 meters, and that would give us a circumference of 1.256 meters. We can also calculate the angular velocity, and remember we want that in terms of radians per second, so we're going to need to take that 20 revolutions and convert it to radians and then divide it by our time. So angular velocity equals the change in our angle divided by time. So if we have 20 revolutions, we would take 20 times 360 degrees, because that's the degrees for one circle. That would give us the value in terms of degrees, and then we would multiply it by pi divided by 180 to get that in the units of radians. So that would give us 125.6 radians in 5 seconds. We want the radians per second, so we would take 125.6 divided by 5, and that'll give us an angular velocity of 25.12 radians per second. Once we've calculated the angular velocity, then we can calculate the tangential velocity. So we have the ball, and we're swinging it around in a circle on a string, and the ball breaks loose of that circle and flies tangent to the circle. We want to know how fast it's going. So we're going to take the angular velocity and multiply it by the radius. So we would take 25.12 radians per second, which is the angular velocity. We would multiply it by 0.20 meters, which is the radius that the ball was traveling in before it broke loose. And that would give us a tangential velocity of 5.024 meters per second. So what that means is we have this ball, It's attached to a string. It's being swung in a circle, so it's got an angular velocity of 25.12 radians per second. And imagine that that string breaks and the ball flies off tangent to that circle. The velocity of that ball tangent to the circle would be 5.024 meters per second.